All right, so page 13, radical equations. So when it comes to radical equations, it's almost like solving quadratic equations in the way that you're still dealing with inverses, but that inverse is kind of the reverse of what we learned when we were doing quadratics. Because instead of taking a square root at the end, we're going to square at the end. Why would I square? It gets rid of the radical. So that's the thing with solving square roots. We're using inverse operations, specifically taking a square root and squaring. Now, it also depends on the radical, because we will come to see some cube root equations. And how would you undo a cube root? Cube it. How would you undo a fourth root? Fourth it. How would you undo a hundredth root? Raise to the 100th power. So, in other words, whatever that index is of the root, or that little tiny number outside the root, that's what you raise it to the power of. All right. So, let's do a stupidly simple one. Letter A. What's the only thing I got to do to solve for x? Square both sides. What happens to the square root and the square over here?
It disappears.
They cancel out. So I got x is equal to what? All right. Now, this next one. So, what's the issue I'm running into here?
It's the 1/2. It's like a square root.
It's to the 1/2, which is a square root. So remember, anything raised to the 1/2 power is a square root. So I'm going to rewrite it so that it has a square root. All right, so I haven't done anything to solve yet. I just rewrote that 1/2 power to be a square root. Yep, now we can square both sides. You could have squared both sides off the bat if you wanted to, but sometimes just for consistency's sake, it's easier to just see it with the square roots because that's what we're used to. So now, why would I go ahead and square it and not add the 3 to the other side? It's all under the radical, so technically it's in the what?
Oh, it's not in order. It's like it's in sadness. It's in exponents. It's in backwards and us.
So the square root's the exponent. What's the x minus 3? Nope.
That's square root. That's like the second, or that's the second to last thing.
Look at what it's originally in. X minus 3 is technically in parentheses. So that's why we can't touch it first. All right. If we do SADMEP, which is just reverse PEMDAS, which is how you should solve these equations, you would square it first. So I have x minus 3 is equal to 25. What do I do next? Add the 3. So x is equal to 28. Say it one more time. Positive what? So we're not doing positive or negative because we're not taking a square root. We're squaring it. So with squaring, remember, whenever you square something, it's going to end up being positive anyway. No number that you square will end up being negative unless it's like imaginary, but we don't deal with those in this unit. So that's why with quadratics, taking a square root, it could be the positive or negative version of that square root. So like the square root of 9 could be either positive or negative 3, whereas 9 squared is definitively 81. Does that make sense? All right, try letter C on your own. So it's pretty much the same process as B, except instead of a 1 step at the end, you end up with a 2 step. first one? What are you doing?
My dad speaks in Jamaican. I swear that.
All right, thumbs up if you're ready. All right, so what is my first step? Let's go, Jesse.
I actually didn't get the answer yet.
That's okay. What's my first step?
I'm not sure. I just got here. I was trying to write the other number B out.
Okay, so let's talk through it. So is the square root by itself?
No. Yes.
Yeah, there's nothing else outside of it. So technically we can go ahead and do what to get rid of it?
I don't know. Square.
Square it. There you go. So square both sides. That goes away. 2x minus 1 is equal to 16. All right, what do I do next? Let's go Carson. Add the 1 to both sides. So I get 2x is equal to 17. Let's just put it on the filing cabinet. All right, Riley, what's the last step? Divide by 2. So x, you can either leave it as the 17 halves, or if you wanted to write it as a decimal because it's an easy one, it's 8.5. I would accept it either one of those. Rule of thumb, guys, when in doubt, leave it as a fraction. All right, if it's not going to be a pretty number when you divide it, leave it as a fraction. Just makes your life easier in the long run. All right, now letter D, little bit different. Because what's the issue with letter D? It's the 1/2, first off, but when I rewrite this with the square root, what's the only thing that's going to be square rooted? Nope. It's just the x. Why?
Because 3 is
It's not in parentheses. So remember, if it's like this, then yeah, the 3 will be included under the radical, but it's not. It's only the x. Remember, I've been drilling that in you with your calculator stuff for a while. Same thing applies here. So, if I rewrite this, this will be 3 square root x minus 4 equals 20. Now, this is where SADMEP comes in handy because the hardest part with these is figuring out when to square. Because right now, squaring is not a good idea. All right. Right, I should add the 4 first because if we look at SADMEP, I got to take care of subtraction addition first. So that's gone, and I can cross that out. This will be 3 square root x is equal to 24. What do I do next? Divide by 3 because I got to take care of the multiplication division. That goes away. I get the square root of x is equal to 8. Now, the square root is technically an exponent. So how do I take care of it? Square both sides. That goes away. X is equal to what? 64. And we don't have parentheses, so I can cross out all of that. So that's kind of a way that you can think about as you're doing these. If you have issues with figuring out what you do first, write SADMEP on your paper, cross out as you go. All right. Let's try another one. So letter E is going to have everything in SADMEP. All right. So based off of SADMEP, what's the first thing I do? Subtract the 7. Good. That goes away. I get 2 square root x plus 5 is equal to 6. What do I do next? Divide by 2 because that's my multiplication division. I have the square root of x plus 5 is equal to 3. Right. Now that everything outside of the radical is taken care of, I can square both sides. That goes away. X plus 5 is equal to 9. So that's my exponent aspect. And then lastly, what was in the parentheses. So I subtract the 5. X is equal to 4. How do you guys feel with these? All right, try letter F on your own. I'll leave up E because it's similar. So try letter F on your own. And by the way, guys, these are the simple ones.
It's the minus 4. Secret geniuses.
It is not sure.
I
I didn't really know how to spot it. I'll say it's got.
That's not very much.
Wait.
That's very much so
You plug it,
Oh, right. There's a new one. It's just, it's right.
Is that why I made it in.
They must have messed up since.
I told you. They saw the potential. Yeah.
Did you solve it or did you look off Richard's paper?
I definitely looked up. Yeah, what?
Evan Richard look at mine.
No, I can't even read your hand.
Me either, it's okay.
She
That's
can't
how.
either.
I did mine before his.
Well, my final answer. That's like the main important. I need other people to understand my
You
process.
remember whatever.
Technically, your teacher doesn't understand your process, but you don't get points back.
Why? What?
Well, like,
What? Like I can do a lot of it. I have the.
you know, why do we agree to do it? Like,
That's not very nice for me.
aliens in Florida.
You should have. What do you want to do?
It's like really smart.
Just the fractionalized
That might have been the case.
I sure do.
I'm not rich. I'm broke.
He loves to mention that. I don't know why.
I'm
Wait,
broke.
Yeah, he's
for
like.
how much you say?
He's like all those influences, like the room.
All right. Shh. Looking around, looks like most of y'all are done. So let's see who's under the chopping block. Colden, what's my first move? Yeah, we'll add the 4. Sorry, Riley just said something very stupid.
Sounds like my.
Yeah. So that's how Rishi motivated. He was talking about Kim Kardashian.
What was he talking about, Riley? Okay, it doesn't matter. It doesn't matter. Kim Kardashian. Okay, last time I checked, no one in this class is named Milk. Oh, dear God.
All right, take it over.
All right, Peyton, what's the next move? Yep. So we've subtracted the 4, or added the 4. So what do we do next? Good. Y'all, shut up. Just, like, that's how done I am right now. All right, next one, Fisher. What do I do next?
You square the you square the
Square both sides. Boys, do I need to separate you? All right, next, Maxon. Good. This is 3x. This is equals 66. Last step. Charlie. Good. So x equals 22. How'd y'all do? Good. All right, last one I want to do in this section. Shh. All right, last one I want to do in this section is letter G. So what's kind of the difference between G and the ones we've been doing?
It's a cube root.
It's a cube root. So the process is essentially the same, except instead of squaring to get rid of the root, what we have to do? We have to cube it. All right. So what's my first move? Subtract the 5. So this would be the cube root x minus 7 is equal to 4. Now, the cube root's by itself. So to get rid of that, we have to cube both sides. So that goes away. So x minus 7 is equal to 64. And then add the 7, right? So x is equal to 71. So just make sure you pay attention to the type of root that you have. The steps are essentially the same, but depending on the type of root, depends on what you need to raise each side to when you get the root by itself. All right, so just be careful with that. Now, next thing we're going to do, get to some harder ones. So we're going to consider this system of equations. So y equals the square root of x plus 3 and y equals x plus 1. We're going to graph both of these to solve it by graphically first. So let's start with the easy one, which is x plus 1. How do I graph x plus 1? So the y-intercept is 1 because that's my b value. If you do y equals mx plus b. And then the slope is 1, so I'd go up 1 over 1. So I'm just going to do that for a bunch of points. So pretty much until I run out of graph. So that is the linear graph. Now, the square root graph is not too bad. The way I look at the square root graph is like this. I do a table. Now, my x value is going to depend on the perfect square that I want under the radical. What is the lowest, most perfect square that I can have under a radical without becoming imaginary? 0. So, I'm shooting for the square root of 0 under the radical. So, in other words, what x value, when I add to 3, gives me 0? Negative 3. And then what's the square root of 0? 0. What's my next perfect square after that? So square root of 1. So in other words, we want 1 to end up under the radical. So negative 2 plus 3 is 1. So that's our x value, negative 2. And then what's the square root of 1? 1. So I'm purposely picking numbers that'll give me perfect squares. This is how you graph square root functions. And we'll go more in depth of in this when we get to 5.6. But, oh yeah, it's a whole lesson. It's not exponential. It's radical. So what's my next perfect square? 4. So I'm shooting for 4 under the radical. So what do I need to plug in for x? When I add to 3 will give me 4. 1. What's the square root of 4? And then I can do one more perfect square. What is that perfect square? 9. So what add to 3 will give me 9? 6. And then square root of 9 is 3. So these right here in the table are my points. So I have -3, 0, -2, 1, 1, 2, and 6, 3. So 4. So the graph looks like this. Now, why do you think I'm not drawing an arrow down? It's not real numbers. So remember, on graphs, we can only graph real numbers, not imaginary. And when do we have imaginaries in a square root function? Negatives under the radical, right? Now, if we were to solve this system, what are we looking for? Nope. Solving this system of equations, what do we look for? The intersection. So the point of intersection is right here. That's why I wanted to get a bunch of points. So we get the exact point of intersection. What is that point? 1, 2. Now, if I just solve for x, what's the x value? 1. So in other words, if I was just strictly solving for x, x would equal 1. Now, algebraically, let's actually look at how to do this algebraically. So we're going to solve by substitution, meaning we're just going to set both of these equal to each other. So I have the square root of x plus 3 is equal to x plus 1. Now, this is what I meant when I said we're getting into more difficult territory. All right. So the radical is already by itself. It's all based off of the radical. So the radical is by itself. So logically, what's my next move? Square both sides. And by square both sides, I mean put the x plus 1 parentheses and then square it. Don't square it individually. So this goes away. I have x plus 3 is equal to x plus 1 squared. Now, from the quadratic unit, we know what x plus 1 squared should look like, right? So if I expand x plus 1 squared, what is that?
X squared plus 2x plus 1.
Good. So remember, it's not x squared plus 1 because x plus 1 squared is the same thing as x plus 1 times x plus 1. So you either have to do a quick FOIL or a box method if you don't know what it is right off the bat, but it's a perfect square trinomial. So this would be x plus 3 is equal to x squared plus 2x plus 1. Now, what type of equation is this? It's quadratic. So what do we got to do to solve a quadratic? Not yet.
You gotta move it all on one side.
Get one side equal to 0. So I'm going to move the non-x squared side to the other side. So 0 is equal to x squared plus x minus 2. Now, you always want to hope and pray that it's a solving by factoring, which in this case it is. All right. So more often than not, if I give you one like this, you should be able to solve it by factoring. All right. So solve by factoring. Do I even need to do big X, or do you want me to, like, what do you want me to do? Okay, so I'll do big X first. What goes on the top? -2x squared. What goes on the bottom? X. A times C. So 2 factors that multiply to -2 add to 1. Nope. Positive 2x and -1x because we're adding to a positive. Now, you could just go, since the A value is 1, you could just go straight to the factors. But if that's not kind of your thing, you can always do a T method or reverse box. I'm going to do a reverse box. So I have x squared, -1x, 2x, and -2. So I took these to replace the x. Now, what's the GCF of the first column? Or what's the GCF of the first row? X. GCF of the second? 2. GCF of the first column? GCF of the second column? -1. First box is negative, so you got to take out a negative. So 0 is equal to x plus 2, x minus 1. What's my last step to solve by factoring? You gotta set both equal to 0 and solve separately. So what's x equal to?
X minus 2 and x plus 1.
So x is equal to the set of -2 and 1. Now, here's kind of the conundrum. Same problem that we solved graphically and algebraically. What's the problem? Well, what's the difference between my answer that I got graphically for x and the answer I got algebraically for x? The -2. We have an extra answer. So we have an extra answer algebraically. There's actually a mathematical phenomenon for that answer. X equals -2 is actually what we call an extraneous solution. Now, extraneous solution is just a fancy way for saying that if we plugged it back in, it won't work. All right? Something about it won't work, whether we won't get the same number equal to another number or it makes it undefined, something like that. So in other words, we'll end up with a negative under the radical, which we know will give us a imaginary number, or the two values won't be equal to each other. So let's just do a quick check. If I plug in -2 back into my original equation, so I have the square root of -2 plus 3 is equal to -2 plus 1. All right. What's -2 plus 3? +1. So I got the square root of 1 is equal to, what's -2 plus 1? -1.
So wouldn't it be plus minus 1?
Nope. Nope. What's the square root of 1? 1.
Why isn't it plus minus?
Because it doesn't work for a square root function. You can't get a negative number on a square root function. So it's extraneous because we didn't get the same solution when we plugged it back in. And again, it's just a mathematical phenomenon that happens, specifically when we start like solving and then you throw a quadratic into the mix. Now, easy thing to do with extraneous solutions, you know what we do? If they don't work, we nix them. All right, they're not important to us. We only care about the ones that do. All right. Because if I plugged in 1 plus 3 is 4, square root of 4 is 2, 1 plus 1 is 2. That one works. You get the exact same number. All right. So now this one is not necessarily the most obvious extraneous solution, but you also got to think about it this way. There is no way that if you take the square root of a positive number that you're going to get, or how do I phrase this? So if it was -2, -1, it'd be right here, all right, on the graph. But when it comes to square root functions, I know with quadratics, we do the whole plus or minus thing, all right? But that's when we take a square root at the end, yes, because that shows us the possible answers. With square root functions, there's really only one possible answer to them, all right? It's technically what we call, whoever's phone that is, turn it off. It's technically what we call a one-to-one function, meaning there's only one y value for every x value. All right. That's why it still happens, because we had that quadratic, and typically quadratics give us two answers. Now, does that mean that every time you end up solving a quadratic in a square root function that you're going to have an extraneous solution? No. Sometimes both work. Sometimes none of them work. All right. So it's just something that you have to check. And honestly, it can just be as quick as just throwing it into your calculator real quick. All right. Moral of the story, check your answers. All right. So let's do another one of these. So let's look at letter B. So, letter B. Now, what's kind of the glaring issue for letter B?
It's got the thing. It's got a coefficient.
Well, it's got a coefficient. That's not really a big deal. We got x's. It's going to be like the one we just did. It has the -2. That's the glaringly obvious thing that we need to move. So we got to get the radical by itself before we can square both sides. So I got to add 2 to both sides. Shh. This would be 2x plus 2 is equal to the square root of x plus 6. Now, just like we did with the previous one, I can square both sides once I get that radical by itself. So you cannot square until the radical's by itself on one side. All right. So this would be x plus 6. Perfect square trinomial, what would it be?
4x squared plus 4x.
8x. Seriously, whoever's phone it is, I'm not going to be mad if you take it out and turn it off, but turn it off.
I don't think it is.
So it'd be 4x squared plus 8x plus 4. Now we're in solving quadratic land. So what do I need to do next? Subtract the x and the 6 to both sides. So I get 4x squared plus 7x minus 2 is equal to 0. Now this one you kind of have to do a big X. What goes on top?
Negative 8x squared.
Negative 8x squared. Bottom? 7x. All right. Now, since we're multiplying to a negative, that means one of them has to be negative. 2 factors of negative 8 that add to 7. 8x and negative 1. Now, do you guys want me to do reverse box or T? I heard T first, so I'll do T. So remember, this is replacing the 7x. So this is 4x squared minus 1x plus 8x minus 2. I'm going to draw my T. What's the GCF of the first group? X. What am I left with?
4x minus.
Good. What do I do next? Bring down the plus. What's the GCF? 2. So this would be 4x minus 1. Bubbles are the same, so we know we did it correctly. What is guaranteed one of my factors? 4x minus 1. Cross those out. What's left? X plus 2. Yep. Set it equal to 0. Set both of these equal to 0, and you can solve those. So those are both 1 and 2 step equations. I'm not doing that. So x is equal to 1/4, and x is equal to -2. Now, we cannot take these at face value. We got to check for extraneous solutions. So take like the 2 seconds to check your extraneous solutions. So I'm going to check for x equals -1/4 first. Plug it into the original. All right. So I have 2 times 1/4 is equal to the square root of 1/4 plus 6 minus 2. 2 times, it's right. 2 times 1/4 is 1/2. So 6, if I change that to have a denominator 4, that'll be 24 over 4. So that'll be the square root of 25 over 4 minus 2. 25 and 4 are both perfect squares, meaning I can square root that. So this is 1/2 is equal to 5 over 2 minus 2. 2 we can change to 4 over 2. So 1/2 is equal to 1/2. It works. Also, you could have thrown that into your calculator. You gotten the same thing.
Wait, so it can't be negative, so it's not just immediately ruled out.
Not necessarily. Like sometimes if you have a negative x value as your answer, it still works. It's more so like when you plug it back in, it's more so if the answers don't match. And what typically will happen is that you'll have the positive of one, the negative of the other. So I'm going to check x equals -2. So I have 2 times -2 is equal to the square root of -2 plus 6 minus 2. So that's -4. -2 plus 6 is 4. Square root of 4 is 2. So that would be 2 minus 2. So negative.
Why don't we do the plus minus?
Huh?
Why don't we do plus minus 2 here?
Because we can't with radicals. So with radical functions, think about it this way. When you square something, it's always going to be what? If it's a real number.
Wait,
So
positive?
regardless of the number, it's when you square it, it's always going to be positive. So because we're solving for radicals, when we take the square roots, we have to undo it with a square. So in other words, when we plug that number back in, we should not be getting a negative number at the end. Does that make sense?
Mhm.
So because -4 does not equal 0, not one of our answers, x minus 2 is extraneous. We throw it out. Our answer is x equals 1/4. So again, guys, take the extra time, even if it's just throwing it into your calculator and seeing if both sides match, take the extra time and just check. All right? Because I can guarantee the one time you don't check, there's going to be an extraneous solution. All right? And I can tell you right now, if you give me both solutions and one of them is extraneous, I'm taking a point off.
Will you take all the credit?
Not all, but you'll lose some.
That's if you do what?
If there's an extraneous solution and you just gave me both the answers and you didn't check for extraneous and there is an extraneous and you didn't throw it out. All right, now, those are kind of the, not necessarily the harder ones, but they're kind of the pain in the butt ones, I like to say. Now, these next couple of ones, fractional exponents. All right. So, now the biggest thing with these fractional exponents, you don't even have to convert them to radicals. All right. The easiest way to do it is to just multiply, or not multiply, raise each side to its reciprocal power to remove the fractional exponent. Just like when you solve a two-step equation, if you have a coefficient that's a fraction, you multiply both sides by its reciprocal. Same concept here. So, now you could switch it if you want to. So I'll do both ways for this first one. So the first way is what we're used to, where we're converting the fraction to radicals. So the 3/4 is only affecting what? The x. So how would that convert to a radical? What type of radical is it going to be? It's a 4th root because that's my denominator, and x is going to be raised to what power? 3. All right. So I'm going to add 7 to both sides. I get 2 4th root of x cubed is equal to 16. Divide by 2. Now, I have the 4th root of x cubed is equal to 8. All right. Right. You got to raise both sides to the 4th power to get rid of it. So, I have x cubed is equal to what? 44,000 what?
4096.
496, that's what it is. 4496.
No, 4096.
4096. Again, you can just put that in your calculator. Now, that's a big number to take a cube root for. Luckily, this is a perfect opportunity to show you how to take a cube root in your calculator. So, now, this is how you take a cube root in your calculator. Do not hit second and then the square root key because, remember, a square root has an invisible index of 2. And your calculator, the square root key, has that 2 saved in it. So if you click it, it's going to think it's a square root, regardless of however you click it. But if you go to your calculator, you hit the math key. So that math key is right below that green alpha key. All right. Do you guys see right here, number 4? See right there? There's a cube root. So if you hit 4, it'll input the cube root for you. All right. The other way you could do it is you type a 3 in, then hit math. Now, do you guys see the 5 right here where it has a little x and then a radical? This is the one you use for any root besides a square root or a cube root. So 4th root, 5th root, etc. In this case, you can still use it for cube root or square root. But if I hit 5, it'll generate so that the cube is up there. All right. And then I can put in my numbers. So 40, 96. The answer is 16. So that goes away. X is equal to 16. Now, since we had to deal with a cube, all right, is there going to be a plus minus here? No, because with cubes, is it possible to get negative answers? Yes. If you cube a negative number, you're going to get a negative number. All right. So positive 16 cubed is always going to be positive 4096. All right. Negative 16 cubed is going to be negative 4096. So we just keep the positive. Now, that was if you convert it to a radical, which is fine. The other way, which I think is a little bit quicker. So the other way, which I think is a little bit quicker, is so I'm just going to rewrite it. So we're going to get it down. We're not going to change this to a radical. We're going to leave it as an exponent. So I'm just going to get it down to the x by itself with the exponents. So basically, we're repeating the first 2 steps. Now, we know that a square root undoes a square and vice versa. A square root can be written as what as a fraction? 1/2. So 1/2. So that's the exponent. So 1/2 and 2, how they relate? They're reciprocals of each other. So how do you think I'm going to get rid of 3/4? Raise both sides to the 4/3 power, which is the reciprocal. Now, from there, you can either put that in your calculator or you can convert it to a radical from there. So 8 is equal to the 4/3 power, which remember, that means it'll be a what type of root? Cube root 8 all to the 4th. Cube root of 8 is 2 to the 4th power, 16. So it doesn't matter which way you do it. You can convert to a radical first you can convert to a radical at the beginning, or you can keep the fractional exponents. You just got to make sure you raise it to its reciprocal, whatever makes the most sense to you. Now, the main thing that you got to pay attention to is that occasionally you will end up with some plus minuses. All right. So let's look at one where that might be the case. Look at example 6. So I'm going to do it the way I did the first way first, just so you can see what I mean, because it's easier to see that way. What's my first step? Subtract 9. So this will be x to the 2/3 is equal to 9. Now, I'm going to convert 2/3 to a radical. So what type of radical will it be? Cube roots, and then the x will be what? Squared. So first thing I got to do, or if you want it, you could also do it like this. That's actually a little bit easier. So how do I get rid of that square?
You got like square root.
Square root both sides. Now this is where the plus minus comes in. All right? Because we know that if we're solving and we end up having to take a square root, we have to include the what? Plus minus. So this is the cube root of x is equal to plus minus 3. And then you cube both sides. Right. So x is equal to plus or minus 27. Which makes sense because what's the cube root of positive 27? Positive 3. What's the cube root of negative 3? Sorry, what's the cube root of negative 27? Negative 3. So it works. So that's what you got to be careful with. So basically, how you know, especially if you do it the other way, if you need to put a plus minus.
That's totally cool.
Isn't it plus minus because no matter what you're going to square after you solve it?
Mm-hmm. So let's say I did it the other way. All right. So I have x to the 2/3 is equal to 9. And I multiplied by the reciprocal, which is 3/2. All right, that goes away. I get x is equal to, how do I convert this? Square root of 9 to 3rd power. Now, since we're still in solving mode and we're taking a square root of a number, still got to throw in that plus minus. So x is equal to plus or minus 3, all cubed. So x is still equal to plus or minus 27. Essentially, guys, if you're dealing with a fractional exponent and your numerator, you're solving with fractional exponent and your numerator is positive, not positive, and your numerator is even, you're going to have plus minus. So if you have a 4 there, plus minus. If you have a 6 there, plus minus. But if your numerator is odd, it's not going to be plus minus because you can have negatives when you take those roots. All right, so that's how you tell. All right. Now, we still got to check those answers to make sure we don't have any extraneous. All right. Because even though we get plus minus, we may still have extraneous. So before we do that, let's check. So if I plug this back into the original, all right. So I'm going to check the positive version of 27 first. So I'm actually going to take these squares away. So 27, I'm going to take the cube root and then square it. So what's the cube root of 27? 3 squared. So we have 9 plus 9, which is 18. Is that true? Yes. X equals negative 27. So what's the cube root of negative 27? Negative 3. What's negative 3 squared? 9. 9 plus 9, is that equal to 18? Yes. So if you do get a plus or minus, just make sure you double check because sometimes you do end up with an extraneous. It's rare, but it happens. Any questions on that? Okay. Last one I wanted to do, look on the next page, specifically at number 9. So, square roots on both sides, that's actually really easy to take care of. You just square both sides. All right. So, square root of both sides, as long as the square roots are by themselves, you can just square both sides and be done with it. So, this will be 5x minus 11 is equal to 2x plus 16. Then from there, it's just a multi-step linear equation. So, I can subtract the 2x, subtract this, or no, add the 11. That goes away, that goes away. I get 3x is equal to 27. Divide by 3. X is equal to what? 9. If I do a quick check, 5 times 9 is 45, minus 11, that is 36, that's 6. 2 times 9 is 18, plus 16, that's...
Wait, no, isn't that
No, that's 8.
34? Because 45 minus 11.
45 minus 11 is 36, that's 6. 2 times 9 is 18, plus 16, that's 34, yeah. Square root of 34. So we actually have an extraneous
Wait, no,
solution.
because isn't 45 minus 11 is 34?
Oh, yeah, it is. So square root of 34 is equal to square root of 34. Yep. My brain's not brain. I'm tired. All right. Now, that's pretty much it. So, that's pretty much it for solving equations. Does anyone have any questions on those? All right. Yes. So the plus and minus is really only when you have... The plus or minus is really when you only have fractional exponents that the numerator is not 1. Specifically, that's when you have to check for the plus or minus. So like if you look back at these two examples, if your numerator is odd, you don't have to do a plus minus. Sorry, did a stupid. Give me 1 second. Oh, now it works. So if your numerator is odd, then no plus minus. If that numerator is odd. If it's even, yes, plus minus. All right. And that's when you first start. All right. So at the very beginning, when you start, if that original numerator is even, yes, you need to throw a plus minus in there. If it's not, you do. You don't. Does that make sense? All right. So you guys got a solid 20 minutes until the end of class. I expect you to be working on your Delta Math, which is there is a new one. Yep, new one.